Hello everyone, and welcome to another day of Advent of Code. Today is December 6th, and I'll be doing day 5 today. So let's get into it. Let's see. All right. Oh, one thing I wanted to mention before I got started here is I made a small tweak to my test runner, or my testing harness here, so that it will allow me to not have to go back and forth and make changes to this as far as which things run and which don't. So for example, if I go here and I say console.log health calories, when I run node index.mjs1, it's only going to run the console log for our example inputs and not for our real input. The real inputs are huge, and it usually just like completely clobbers all the console. So I just made that small tweak there just to make my life a little bit easier as I'm solving these puzzles. All right, so with that, we're going to create a new folder for 05. And I'm going to call this one input.txt for the input, solve.mjs for the actual JavaScript file. This is going to need export function solve1 that takes in lines, and do that for solve2 as well. All right, so with that, I should now just be able to run 5, and we've got undefined is our output as expected. All right, let's hop over to Advent of Code and check out this puzzle. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will arrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks and the rearrangement procedure, your puzzle input. For example, interesting. So this is the first time we're getting like a diagram type thing in our input, as well as some line-by-line instructions. So this is going to be a little bit different this time. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates, Z at the bottom, N is at the top. 2 contains 3 crates, M, C, and D. Finally, stack 3 has only P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in this configuration. Okay, so from here to here. Got it. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved one at a time, so the first crate had to be moved with D and then N and then Z. And okay, great. Then both crates are moved from stack 2 to stack 1. Again, it reverses the order. That makes sense. Finally, 1 crate is moved from stack 1 to stack 2. Elves just need to know which crate will end up on the top of each stack. Okay, so our output would be CMZ. Interesting. Oh, this is going to be a fun one, and it will probably take a little bit longer than the previous ones. So let's see what I can do about that. So here's my input. Oh, this should be example input. So let's make this example.1.input.txt. And my output is going to be CMZ. Example.1.output.txt. All right, so if we run this again, expected CMZ got undefined. Perfect. And let's go ahead and grab the puzzle input. Wow, that's a lot of crates. And this kind of feels like a Towers of Hanoi kind of thing, except for I guess you don't have the constraint of having to have certain things can't be on top of other things according to size. So that's good. Okay, so we haven't really specifically tackled this in the past, but there are two parts to solving each of these. Number one is parsing the input. Luckily, I have this that will automatically kind of parse the input as far as reading it from the file, getting it into lines. But we're going to need to do a bit more work today to get the input into something that we can actually use. So what we can do here is let's first of all think about, well, these are arranged. We've got horizontal rows here, but the stacks are vertical. So basically we need to parse this by being able to look at the different columns rather than rows. And let me look at my actual input here. How many towers do we have? Only 9. That's good. If there was 10, that would make it so that the number of characters in a column might be different. So we only have a single character, and we've got one here, 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 and here. So this is index 0 where my cursor is right here. Index 1 has a value. Index 2 does not, because it's just the box thing. We don't really care about that. Index 3 has a space. Index 4 has another thing, so we don't care. So index 5, so right now we're at 1 and 5 have content. 6, 7, 8, 9, 1, 5, 9. We're starting to see a pattern here. We increment by 4 to read the different stack values, right? Okay, so I think we can maybe get started with parsing that way. And this is probably going to be the same parsing logic for part A and part B. So I'm just going to create a function for this, and I'm going to say function parse input. It's going to take in the lines, and it will output. We probably just want to know, well, I'll get to that in a minute. Okay, so we will say, so we take the first line, and we are going to look at, we're going to iterate starting at index 1 and going until we get to the end of the line and adding 4 to the index each time. So let's try this. For let I equals 1, I is less than, so we're going to be iterating over these. So we'll say for each line var line of lines. Sorry, this should be let. For I've been doing too many different programming languages lately, and this is throwing me off. Okay, so for each line of lines, we are going to say line dot length and I plus equals 4. Okay. All right, so let's parse this. So basically we'll say we've got a collection of arrays. We don't know how long it is yet. So maybe we say const stacks, okay, equals this. And you know what? These stacks start with 1. I kind of don't like having to adjust my math on every single thing because in JavaScript, arrays are going to be 0-based. These are going to be 1-based. I mean, I guess I could subtract or add or whatever, but when we get from here, like the numbers, it would be really nice if I could just use them as numbers as is and not have to adjust them. So I'm actually going to put something into the stack already. I'm just going to put an empty stack. We're going to say that's 0. It never contains anything. We're just basically going to ignore it. Okay. Okay, so then the other thing that we need to do here is, so we're iterating through the line, but we also need to know, according to this I, what stack number are we on? So maybe we need to do a little bit more math, say something like const stack index is going to be equal to, let's do I divided by 4. So that will give us, with 1, we would end up with 0. With 5, we would end up with 1. So we need to do an adjustment of adding 1 to the end, and that will give us our actual stack number. Okay, so then what we're going to do is grab that character at that position. So we can say line dot, oh man, dot char at position is going to be I. So we'll say line dot. So we'll say const char equals that. And we will say if char exists, because it might just be, oh, but it might be a space, right? So if char is not equal to space, then we're going to push it into that stack, right? But the stacks may not exist already. We're going to add them as needed. In the example, we only have 3 stacks. In the real one, we have 9. So we're going to say if stacks at stack index exists, or rather if it doesn't exist, we're going to say stacks at that index is going to be set to an empty array. So that way that we should be able to do that. Now, I really want to know though, is that going to work? So let's just drop in Node and see. Okay, so let's say let stacks equals an array with some array in it. Okay, so if we stacks and stacks.length, we have 1. Okay, that's great. But let's say, because we're not always going to be adding these stacks in order, let's say we say stacks at position 4, right? It's undefined. So we say set that to a new array. Okay, now let's look at stacks. And we have that, and the length of stacks is 5. So that's great. It will automatically allocate empty items for us when we do this. And you know what? Knowing that, we don't even necessarily need to have that starting thing in there. It will just insert an empty item for us at the beginning of the array, and we don't have to worry. So that's kind of neat. Okay, so let's see. We're going to put it there, and then we just need to pass this chart into that stack. So we'll say stacks at stack index dot push that chart. Okay, so let's go ahead and look at this. So we're doing this for each line. Now, at some point, we're going to run out of lines that we need to do this for. So we need to basically look for a line that does not start with that character. But the first line's not going to start with that character. So that's going to be a bit of an issue. Maybe we look for a line where character at index 1 is 1, right? So we can just say, so each line, and we will say, let parsing start state equals true. And we will say, we're iterating through the lines. You know, I kind of don't like how we're doing this, because then if we bail out of this, then we'll lose our index of that. So maybe we'll make this an old-fashioned while loop. We will keep track of let line index equals 0. And we will say while line index is while parsing start state, we're going to do this, and we're going to increment the line index each loop iteration. Okay, so that way we should be able to stop, but we won't lose our line index. We won't lose where in the puzzle input we are. Okay, so let's see. So we put our stacks together, we increment it, but we need to, before we start analyzing that line, we need to check to see if we're done with parsing the start state. And I was actually just thinking, if we are done with that condition, we probably just break out of the loop. So maybe we don't even worry about that, and we can just say while true. Kind of boring, awful way of doing it, in my opinion, but it will work here. So we'll say if, oh, you know what? We could even just say while line index is less than line stop length. That way we don't have any possibility we will get into an endless loop if this if condition doesn't work. Okay, so we're going to say if line, oh, we need to define line. Const line equals lines at line index. Okay. So if line dot char at position 1 in the string, so it should be, this is 0, this is 1. If it is equal to 1, then we break out of the loop. We know that we are done parsing that. At this point, I really, really want to test this. So parse input lines, and let's do a console log of the result. So maybe we just say console.log stacks. Okay, so let's get out of node, and we will do node index.mjs 5. Okay, so let's take a look at what we got out of this. So we see 1.25, 2.25, 3.25, 5.25. That is rather confusing. Something got messed up in our process. Our line number should start, stack index. Oh, right, because we're dividing by 4. Let's math.floor this. .floor. We're not doing integer division. This is JavaScript after all. Okay, let's see if this is better. So we've got our first stack as DNZ. Well, that's a problem. That's not right. And then we've got, obviously this did not work. Line index plus plus. Maybe let's console log that line out. Make sure that we're still getting this the way. Okay, so it's going through the entire input here. And this is kind of interesting to me because it looks like when it's passing this in, oh snap. So I'm getting bitten a little bit by this because I was trimming each line, trimming the start and end of each line. Can we just do trim end? I don't want to trim the start because this layout is going to be messed up if I trim the start of the line. Okay, so let's run this one more time, see what we get. All right, so wait, did that not? We still have it trimmed. Oh, that's kind of sad. Oh, it's probably because I didn't fix it in the other spot too. I'm doing more than one trim in this. Trim. Yeah, so this was trimming the entire file, but I also need to trim end on the line. Okay, does that fix things? Yes, yes it does. Okay, so we got NZ, DCM, and P. Great. Now, the only thing I'm thinking now is that although these appear top to bottom, I'm thinking about, we're using a JavaScript array here, and I know that JavaScript arrays can act as a stack. A stack is a data structure that allows you to basically only deal with the top item on the stack. So you can remove it. You can push. When we're pushing, we were pushing onto the top of these stacks. Now, you can use it in other ways like that, but I do know that they specifically have a push and pop, which are stack operations that I can take advantage of here. But if I want to use that, I'm realizing now if I pop, that's going to give me a Z. That's the bottom item, and I don't want the bottom item, I want the top item. So each of these stacks I actually need to reverse. Luckily, JavaScript has a way of doing that. So let's close this, come back to our solve.mjs, and close others. Okay, so we've got our stacks, but let's reverse each of the stacks. So we'll say stacks dot for each s dot reverse. And I believe this does it in place. Yes. So this will modify the array. Okay, so now if I run this again, we now have Zn, MCD, and P. So if I pop off of this stack, it will give me N, which is what I want. D is on top of this, P is on top of that. Excellent. We have our starting state. Now we just need to parse the rest. So again, we have our line index here, so we know where we left off. So I'm going to go ahead and remove this console log for a minute. And what we're going to do here is start parsing these moves. First of all, we broke out of the loop before we incremented the line index. So we will still have the line index pointing at this row here. We want to move 1, 2 rows down, and then we can go to the end of the file. So we'll say line index plus equals 2, and then we can do another while loop very similar to this one, and we will have a line index plus plus here. And just to test, we are not in an endless loop. It still runs very, very quickly and doesn't get stuck. So each of these lines, we're going to have to const line equals lines at line index. Each of these lines are going to have a move blank from blank to blank. Now, if we look at our actual input, we have 11. Oh, so we can't just say, like we were here, we're going to be at position 1, 4, 9, 13 in this string. We're going to need to be able to read an entire number from the string. Now, there's going to be a number of different ways we could tackle this. We could just say, let's split on the space character. So then we would have index 0 would be move, which we actually don't care about. Index 1 would be the number of things to move. Index 2, we don't care about. Index 3 is the source. Index 4 we don't care about. Index 5 would be the destination. That seems like a pretty reasonable way to go about it. Another way you could tackle it is using regular expressions. So you could create an expression saying, we're going to have some number of word characters, and then we're going to have a space, and then we're going to have some amount of digit characters, and then we're going to have a space, and then, well, we don't even need to say word characters. We could literally say move and from, right? And then we could say there's going to be one number there. We know that the source and destination won't be more than one number. 2, and then /d again. So that you could use a regular expression to do that. But I feel like the string splitting is probably going to be a little bit more straightforward. So let's go with that solution. Line dot split on the space. Okay, so this will give us segments. Const segments. Okay, so then we need a collection of commands. So here we'll say const commands equals this array here, and we will say commands dot push And we can give it an object here so that we can give it more meaning to what these different things are in the value. So we'll say amount, and that's going to equal a number representation of segments at index 1. And this needs to be a colon and no semicolon. So again, this plus just forces this value, which will come in as a string, to be parsed as a number. We could also use the number constructor like that to do the same thing. Or you could even use, I think there's parse int, although I haven't used that in a very long time. So this is kind of the shorthand. Okay, amount is going to be numeric of that. We're going to say source is going to be numeric version of segments at index 3. And destination is going to be the numeric version of segments at position 5. Did I get that right? 0, 1, 2, 3, 4, 5. Okay, so let's console.log our commands and see if we got that parsing correct. Okay, so we've got, let's go to our example input, 1, 2, 1, 3, 1, 3, 2, 2, 1, 1, 1, 2. We have parsed the stacks, we have parsed the commands. Now we are ready to move on to our actual algorithm of how to solve this. Okay, so let me remove the console logs that I've put so far so that we don't cause ourselves any unnecessary grief. Oh, but we do need to return something out of this parse input function. And here I'm going to say return, and I'm just going to say stacks and commands. Again, this is shorthand in JavaScript to say stacks is going to be equal to stacks, and commands is going to be equal to commands. Okay, so let's try this. And okay, so for this, we're going to say, we're going to parse the input. Let's just console log the input. Log, we'll say const input equals input. Okay, so if we run this, we have our stacks and our commands. Great. And we can even destructure this in JavaScript by saying we know there's going to be a stacks property here and a commands property here. So now they're, just standalone variables rather than me having to say input.stacks, input.commands every single time. Okay, so now what do we do? So we want to basically run through all of the commands and then see what ends up happening in the end. So we will say commands.forEach. What are we going to do? So we're going to, for the number of times in amount, so we'll say for let I equals 0, I is less than, then command dot amount I plus plus, and that should work because if we are moving amount 1, we'll start out at 0. That's less than 1. It will go through one loop, and then when we increment, it will be 1, which is not less than 1, so it will not do it more than once. Okay, so what are we going to do? So we're going to basically we'll say const crate equals stacks at, oh, yeah, so this is stacks here, so this is good. Stacks at command dot source dot pop. So we're going to pop one off of the source stack. That's like grabbing the thing and holding it in front of you. We're calling that crate. And pop will actually remove it from the array and return it. Great. So now that stack does not have that crate on it. Let's go ahead and put it on the destination one. So we will say stacks at command.destination.push that crate. Okay, so again, we're going to grab one and stick it on the other stack. We're going to do that as many times as the amount dictates. I think that's it. I think that's all we have to do, because we'll run through every command and do that. Let's console.log our result when we're done. So we're going to say stacks commands. We'll do a before and an after and see what it looks like. Okay, so let's make this bigger. So before we have 1, 2, 1, all that. After, we have to look at the Advent of Code to see what their ending state is, and if ours matches it, we have CM and then ZNDP. So we have CM and ZNDP. All right. So now the last thing that we need to do is figure out which ones are on top at the end. So again, when we're looking at the top for a, we could do a peek or a pop. I think we can do peek on an array. Let's see. Dot peek. Nope, that's sad. But we can, so we could say, so let's just say like 1, 2, 3. Whoops. And we can say at position 1, right? Really, we want to see what's at position 0, which meaning like the top, right? But here we have our stacks reversed, and so our top thing's going to be at the last thing in the array. So what we're going to say is basically, so we'll say, let's say let answer equals, and we'll have an array, and let's just collect all those items from the end of the array. We could pop them, I don't know. It just feels weird to me to like disturb the ending state. I want to keep that pristine and just collect the observation of it. So we'll say stacks.forEach, and we will say answer.push the last thing on the stack. So s at s.length -1. And that should give us the last element of the array without going over the end. And then we can, and let's remove these console logs here. We can just take that answer and we will say return answer.join with no character in between. That will take this array, which will have a bunch of characters in it, and give us a string that just basically combines all those characters together. So if we run this now, I would expect it to say that it succeeded. And it is correct. So I have confidence. I'm going to go to the Advent of Code website and submit my answer. Let's see what happens. Woohoo! We got it. All right, part 2. I'm afraid to know what happens next. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane and you quickly wipe it away. The crane isn't a crate mover 9000. It's a crate mover 9001. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Aha! Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. So single crate, you move it there. Great. The action of moving 3 crates from stack 1 to 3 means that those 3 are moved and stay in the same order, resulting in this configuration. So you pick up that whole pile and just stick it on top. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. Finally, a single crate is still moved from stack 1 to stack 2, but now it's crate C that gets moved. So we end up with MCD. All right, well that changes things a little bit, but not too much for the code that we've written. Again, I said that the parsing is going to be the same between part 1 and part 2. It's only the algorithm that is going to be different between these. Example.2.output.txt. And that's going to be MCD. Input will remain the same for part 2's example. Okay, so now if I run this again, it says I was expecting for part 2 to get MCD. We didn't get anything. Let's fix that. So solve.mjs, we're going to close the others. And here we can actually start with a very similar algorithm as we had for solve 1. We're just going to make a little bit of a tweak to the moving part of the algorithm. So let's close that up and this up. All right, so we're still going to parse the input. For each command, instead of just popping and then pushing it directly onto the next one, we need to see how many end up getting there. So let's actually, we will say for each, there, we want to pop it off. We will need a place to keep track of it for a minute. So we will say const, we'll just call it staging area. Because we can't just move all of the things all at once. I mean, I guess we could with like array slice operations and stuff like that. But I want to keep this as simple as I can. So we're going to say we've got a staging area. We'll take the things off and we'll put them in the staging area. And then we'll put those back onto the new stack. And so this staging area will actually end up being a stack in and of itself. Because if you think about it, let's say we're moving these 3, D, C, and M, right? So we'll first start by moving D into our staging area, and that will end up on the bottom of the stack. And then we'll move C, and that will move to the middle, and M will move to the top of the stack, right? And let's say we're moving it onto P, we would want to have M be the bottom, so then we would pop M off of the stack and put it onto there. And so then we would C and then D. It ends up being a stack that we can use as kind of an intermediary here. So instead of pushing that crate onto here, we're going to push it into the staging area. And then what we can do is once we have completed the entire amount, we take that staging area, we push each of those onto the destination. So we would say staging area dot for each crate goes to stacks command dot destination dot push crate. And hopefully that makes sense the way that I explained it. since we are queuing those things up in the order from top to bottom, to pop them off, but that, if I do for each, that's going to take it from the beginning. We want to take it from the end. So that's easy enough. Let's just reverse, and then we can for each do that. So it's going to be a little bit different than what I said, because we basically push D, and then we push C, and then we push M, and then we're going to reverse it. So we have M, C, D, and then for each we'll do M first, and then it will do C, and then it will do D, which is the order that we want to put them on the stack to do that. Okay, so now if we run the code again, we have our second part is correct, and here we go. QNDWLMGNS is my answer. Woohoo! And it thinks this page is Portuguese. If anyone knows why it thinks, oh, it's probably this up here, huh? Okay, never mind. All right, well, that was a pretty fun puzzle, and not too bad. I think that a lot of people, and I heard some whisperings, although I was trying really not to hear any spoilers. Someone mentioned something about hard coding their input for day 5 into their puzzle so that they wouldn't have to parse it. And I'm glad that we were able to go through the exercise of actually parsing it and turning it into a logical model from the textual model. This has a lot of applications outside of coding puzzles like this. You're going to be working on user interfaces or user-provided data in some sort, whether you're in the front end or the back end at some point. And being able to take the user's data, normalize it into something that is more meaningful is an important skill to have. So anyway, thanks a lot for joining me today. We will try this again tomorrow, doing puzzle 6 for the Advent of Code. So I hope to see you then. Until then, take care of yourself, and we'll see you there.